We have a nice integration problem here. We have a quadratic equation which is y equals x squared plus 4. We need to find the area under the curve using this quadratic equation, and the limits given here is upper limit is 3 and lower limit is 1. We need to use the integration rules to get the area. We know area under the curve A equals integration of b a fx dx. Here fx is the value of y, which is x squared plus 4, and upper limit b is 3, lower limit a is 1. We can put those values and we get integration of 3 1 x squared plus 4 dx. Then we can write x squared plus 4 in two separate integration, and we can write it as equals integration of 3 1 x squared dx plus integration of 3 1 4 dx. We know from integration rules integration of x to the power n equals x to the power n plus 1 divided by n plus 1. We'll apply these rules for the first part, and next we again know integration of a dx equals ax. We'll apply these rules for the second term. So we get, by using these two rules, integration of 3 1 x squared dx becomes x to the power 2 plus 1 divided by 2 plus 1, and the limits are 3 1 plus, if we integrate this one with these rules, we get 4x and the limits are 3 1. Next we can write x cubed by 3, upper limit 3, lower limit 1, plus 4x, upper limit 3, lower limit 1. Then we can put the value of the limits. In first we can put 3 cubed by 3 minus the value of the lower limit, which is 1 cube divided by 3, plus 4 into 3, the upper limit, minus 4 into 1, the lower limit. So if we simplify, we get 3 times 3 is 27 by 3 minus 1 cube is 1 by 3 plus 3 times 4 is 12 minus 4 times 1 is 4. Next we get 27 by 3 minus 1 3 plus 12 minus 4 is 8. For the first two terms we get 3 27 minus 1 plus 8. Next we can write 27 minus 1 is 26 by 3 plus 8, or we can write 3 26 plus 3 times 8 is 24. From here we get 0, 5, 50 by 3, and we get the value of area under the curve as 16.66 square unit approximately. So this is the area under the curve by using integration rules. This is the end of the video. Thanks for watching the video.